We discussed question 7 of A-Level Mathematics Paper 5, Probability and Statistics 1 in May or June of year 2020. The numbers of chocolate bars sold per day in a cinema over a period of 100 days are summarized in the following table. Part A, we need to draw a histogram to represent this information. To draw the histogram, first of all, we need to look at the class width of each classes. The first class has a width of 10. The second class has a width of 5. The third class has a width of 15. The fourth class has a width of 20. And the fifth class has a width of 10. We see that there is an equal width for each classes. When we have unequal width, we need to use the frequency density to draw the histogram. So basically, we are drawing a density histogram. We need to compute the frequency density. The frequency density is the frequency, which is the number of days, divided by the class width. So the first class has a density of 1.8. The second class has a density of 4.8. We take 24 divided by 5. The third class, we take 30 divided by 15. The density is 2. The fourth class has a density of 1. And the fifth class has a density of 0.8. To draw the histogram, the vertical axis is the frequency density, and the horizontal axis is the class boundary. So let's just draw a vertical axis and a horizontal axis here. For the vertical axis, we have a maximum value of 4.8, and that is a frequency density with a maximum of 4.8. So we have 5 as a maximum. We use a scale of 1, 2, 3, 4, and 5. For the horizontal axis, that would give us the class boundary, which denotes the number of chocolate bars sold. So the first class has boundary from 0.5 to 10.5. We can always start from 0.5, then we go up by a scale of 10, 10.5, 20.5, 30.5, 40.5, 50.5, and 60.5. From 0.5 to 10.5, we have a density of 1.8. So 1.8 is somewhere here. You'll be given graph paper during the exam, so you will not have this problem. You can draw perfect scale using the graph paper. The second class has density 4.8, so we go all the way up to 4.8 for the second class. From 10.5 to 15.5. 15.5 is here. So that will give you the second class. The third class has a height of 2. So that should be 2. And then you have until 30.5, which is this part here with a height of 2. And then the fourth class is from 30.5 until 50.5 with a height of 1. So that gives us a height of 1. And the last class has a height of 0.8. So we have a height of 0.8, and that will give us the frequency for the frequency histogram for the number of chocolate bars sold per day in a cinema. And you need to remember to write the title as well. Okay, that gives us part A. For part B, you want to calculate the greatest possible value of the interquartile range for the data. Part B here, to compute the interquartile range. The interquartile range is the difference between the third quartile and the first quartile. So to find the third quartile and the first quartile, first of all, we must determine the class where the first quartile is located. So we look at the location for the first quartile. The location for the first quartile, that is 1/4 of the number of data values. That will give us 25. So data number 25. So we look at the 25th value. The 25th value is in the class from 11 to 15. So we know that Q1 is in class 11 to 15. The third quartile has location 3/4 of 100. That is the 75th value. This 75th value falls in the class from 31 to 50. The 75th value is here. To find the greatest possible value, we are not just asked to find the interquartile range. We just need to find the greatest possible value. So for this case, the greatest possible interquartile range, we take the greatest value of Q3, which is 50, minus the smallest value of Q1, which is 11, and that is 39. So the greatest possible value of the interquartile range is 39. Part C, calculate estimates of the mean and standard deviation of the number of chocolate bars sold. To calculate the mean is given by the sum of XF over the sum of F. X is the midpoint, so we need to find the midpoint of each class. To find the midpoint, we just take the lower class limit, add to the upper class limit, and divide by 2. So 10 plus 1 is 11 divided by 2. We have 5.5. And for the second class, we have 13. The third class is 23. The fourth class is 40.5. The last class is 55.5. That will give us the class midpoint. To find the mean, we need to find the product of the class midpoints and the frequency. So we take 18 multiplied by 5.5, that is 99. Then 24 times 13, that is 312. And you do the same for the rest as well. The third has a value of 690, 810, and 444. After that, you just sum all of these. So the sum of all of these is 2,355. That will give you the sum of XF. The mean is 2,355 divided by total frequency, which is 100. So the mean is 23.6. To find the standard deviation, the standard deviation is the square root of the variance. So we have sum of x squared f over sum of f minus the square of the mean. And to find the standard deviation, we square root the result. You get this formula in a formula sheet, so you don't really have to memorize them. We need to find the square of the class midpoints times f. So you square 5.5, multiply this by 18. Then you have 18 times 5.5 squared. And that is 544.5. Then for this case, second class, you have 24 times 13 squared. And that is 4056. Do the same for the rest. The third has a value of 15870. The fourth has a value of 32805. And the last class has a value of 24642. Add all these and you get 77,917.5. So to compute the standard deviation, we have 77,917.5 divided by 100 minus the square of the mean that we found just now. We have 23.6 and we square this. After that, we take square roots. That should give us a value of 14 points.